Before we dive further, these are the architectural patterns for distributed systems. Here we have master-slave architecture, two-tier client-server architecture, multi-tier client-server architecture, distributed component architecture, peer-to-peer architecture, and service-oriented architecture. However, not all will be covered in this course and in this particular lesson. Let's have a look at the first architectural pattern, which is master-slave. In master-slave, we will have a component named master control process. This is where all the processes happen. Then, there is another component named slave control process, which connect to the master control process. Usually, the slave control process will connect to one or several actuators. One of the example of actuator is a sensor. This is the basic structure of master-slave architectural pattern. Let's make this pattern fancier and add more slave control process. So what is the role of master process? Master control process handle computation and communication, meaning that it coordinates the interaction among slave processes. In master-slave architecture, we can have different kinds of actuators. The coordination among the actuators are handled by the master control process. Therefore, different actuators will be handled by different slave control process. Let's look at the role of slave control process. The role of slave control process is pretty much dedicated to a specific action. For example, one actuator only to collect data. Imagine a thermometer to sense the temperature in the room. The job of the slave is to retrieve the temperature and pass it to the master control to be processed. We could have another actuator to display the temperature and to display the interpretation of the temperature. That is to be handled by another slave. Where do we usually use master-slave architecture? Commonly in real-time application, where we use the most. For example, traffic light system, parking system, and natural disaster monitoring system.